question C on page 4 for Charles' Law is really hiding as 4 separate questions in one. So I'm going to show you what I mean by that. I've written out for you the formulas that you need, so I've placed them out on the right side of the page. And remember, Charles's law is V1 over T1 equals V2 over T2. You're going to be solving for just one of those variables, and you're going to isolate the variable first. Anytime that you use temperature, temperature must be converted to Kelvin. As a reminder, you're never going to use your temperature as data for sig figs. So for Charles's law, the only variable that you look at for sig figs would be volume. For any formula in the gas law unit, you're never going to use temperature as your data for sig figs. Lastly, 2 minor conversions that you're going to need to use is that there's always 1,000 milliliters in 1 liter, and that you're going to take your degree Celsius, which would be given to you in the problem. You're going to add 273 to get your units of Kelvin. So for the first question, it says, suppose a sample in a gas thermometer has a volume of 135 milliliters at 11 degrees Celsius. So there's my volume, 135 milliliters. There's the temperature, 11 degrees Celsius. Just right now, I don't know if that's V1 T1 or if that's V2 T2. It then says indicate what temperature would correspond. So I'm going to ultimately be looking for the temperature. What temperature would correspond to each of the following volumes, assuming that the pressure remains constant? Again, just to make things a little bit easier, I'm going to remove this statement because it's not necessary for us. I'm removing it because it's not going to make a difference in terms of how you solve the problem. It's not information that you needed to know. It's not information that you didn't need to know. It's just not relevant for us. So you're going to indicate the temperature that's going to respond to each of the following volumes. And then they give you 4 different volumes, 113 milliliters, 142 milliliters, 155 milliliters, and 127 milliliters. The reason why I said that this is hiding as 4 separate questions as one is that you're going to be using each one of these volumes separately for each law that you're going to plug into. So let's go ahead and start this as a brand new question. I have to first figure out what data do I have for each one of my conversion factors. So I'm going to start with labeling my units. It says suppose a sample in a gas thermometer has a volume of 135 milliliters. So I know that I have a volume of 135 milliliters, and I know that my temperature is 11 degrees Celsius. I'm now going to look for the temperature because it says indicate what temperature. So now I'm going to look for my temperature that's going to respond to each of the following volumes. Well, the first volume that I'm going to look at is 113 milliliters. If you notice, I wrote them out to the side just because there's not enough room here for me to label it on my on my question. I would encourage you to follow along the same way that I am, just to make things a little bit smoother for you. So I now have to figure out who's V1, T1, V2, and T2. So if I have a volume of 135 milliliters at 11 degrees Celsius, and I'm now looking for the temperature that's going to now be in the different volume, I can just go ahead and say that 135 milliliters goes with 11 degrees Celsius. So I can make this V1 and this T1. That means that the new temperature is my T2 and my new volume is 113 milliliters. For this particular question, your V1 is always going to be 135 milliliters, and your T1 will always be 11 degrees Celsius, because it's asking you for basically what temperature is going to correspond to each of the following volumes. So these now are going to be your new conditions. These right here are my original conditions. I'm looking for my new temperature that's going to relate to each one of the 4 new conditions of volume that they've given me. So that means that I now need to solve for T2. Remember, my formula is V1 over T1 equals V2 over T2. I'm solving for T2, which means that this guy is in the denominator. If isolating variables is a struggle for you, I'm going to go through this in a lot of baby steps. This is going to take a little bit longer because you're trying to get it out of the denominator before you can then get it completely isolated and completely alone. So remember, you have V2 divided by T2, and T2 is in the denominator, so I actually want to get it out of the denominator first. So I'm going to multiply by T2 on both sides. And so now what I've done is I've gotten rid of T2 on this side, which is what I wanted. I've brought it over to the left side. And notice that if I was solving for V2, I would be all set because now I have V2 equals T2 times V1 over T1, but I'm not solving for V2, I'm solving for T2. So now my next step, since I'm left with T2 times V1 over T1 equals V2, my next step will now be to get rid of everyone next to T2. I have to do this one at a time. So I'm going to multiply by T1 on both sides so that I can get T1 out of the denominator. So there goes T1 and it's hanging out next to V2. So now I'm left with T2 times V1 equals V2 times T1. My last step that I'm going to take is now to get rid of V1. So I'm going to divide it on both sides. I got rid of V1 over here, and I've now got T2 by itself. So now I'm left with T2 equals V2 times T1 over V1. And this is my formula set up that I want to use.